paper ID 3897. Surekha.
Yes, sir, I'm here. Yes, sir.
Yeah. Please, ma'am. Welcome.
Yeah, hi all. This is Surekha Mane. I'm going to present my paper named Using AWS Services and L for Software Reliability Engineering Work. And this is the paper that I have done during the internship with Zmetrics, the company in Pune, as a engineer intern of MTech second year. And Professor B.F. Momin was my project guide during this. And this is for the topic C in this conference for intelligence computing technology, cloud computing. So the contents I'm going to here discuss is introduction, literature survey, methodology, results and discussion, conclusion and references. So during the introduction part in the SRC, so what is SRE? It is it takes SRE is nothing but software reliability engineering, which takes the task that historically been done by the operations teams, often manually, and it gives them to the engineers and ops team who use the software and automation to solve the problems and manage the production systems. So we are here to automate some of the tasks that are mandate tasks by using the SRE. Then the next is AWS, it is the Amazon Web Service. So it is a cloud computing platform and APIs which are giving unlimited resources and which will be only we have to pay as a customer, we have to pay only which is used by us. So the customers can be a company or government or can be an individual one. And so it is called as pay as you go. And next is Elk. Elk is nothing but the Elasticsearch, Logstash and Kibana, which is an open source system and which is used for the analysis of the logs, indexing, storage and visualization. So for indexing, we are using Elasticsearch. For the Logstash, we are using for the input slicer and dicer and output writer for the logs. And Kibana, we are using it for the visualization part. Different visualizations we are gathering together on a dashboard to show to a to end user with a raw with the whole data. So the log analysis helps the companies for the decision making by seeing at the dashboards. We can also improve the products and services. So the problem statement in this paper is to design and implement framework for healthcare system and telecom domain using L stack with AWS services to visualize the data on Kibana dashboard. So the literature, some of the papers that I have referred. So first paper was tracking casual order in AWS Lambda application. And it is nothing but the paper, it gives us the gamma ray related information, it's architecture and execution, all that in detail in this paper. Next paper is about the analysis of the health system log files using L stacks. So here it's showing us the in detail the part of the Logstash, how it works, how the ALK stacks is working, and how the visualization that we are doing and how the dashboard will look like, and all that is defined over here. Next paper is about the firehose data that is explained over here. So how the firehose data is understand and how it is available, it is explained in detail in this paper. So fourth paper is about the geo identification of web users through logs using Elk stack. So here the geo identification of the paper of the users are based on the logs that they are accessing using the open source tool as Elk one, and they used a small data set just to demonstrate. So so for the bigger data and all that, how it can be worked, that is in this implementation that we had done in the Zmetrics. The next paper is about the media streaming. So the media streaming in cloud with the special reference to Amazon Web Services, a comprehensive review. In this, there is a media stream which gives the consumption to continuous streaming of video with no buffering issues, with excellent standard and big frequency range. So AWS handles the encoding, computing, data security, credibility, and storing of the data. So detailed study of the media stream and AWS services are in this paper. So next paper is about the battling the CPU bottleneck in Apache Parquet to Arrow conversion using FPGA. So in this, they have the in detail discussion and in detail design of the FPGA accelerator, which will use for the improvement of the speed of loading the data from disk to memory. The next paper is about the efficient surveillance and monitoring using the ELK stack for IoT powered smart buildings. In this paper, they have demonstrated the implementation of smart buildings whose use can be made secure and efficient through robust and surveillance and monitoring by leveraging the ELK stack to ensure the systematic collection of the log data, index the suitability to fetch the required parameters, and visualize in appropriate charts to take the necessary action on the dynamic basis. So here they are using different charts. So in the ELK systems, in the next slides, I will discuss in detail about what are the different charts that are available in the ELK stack. So next paper is about the performance of ELK stack and commercial system in security log analysis. So in this paper, they suggested open source platform ELK stack and to build the big security log analysis system for the small and medium sized enterprises. And the last paper is about the towards latency sensitive cloud native applications. They had provided a comprehensive performance analysis on Amazon public cloud platform. As they address the latency sensitive applications, the main focus is on the delay characteristic. So methodology, there are different tools are available in the market for this log analysis. So some of the tools that I have here compared, first is about the Splunk. So Splunk is the first tool that is developed by the Google, and it is the paid tool. So we have to pay it, and it's an expensive tool. So Sumologic is the second tool that here I'm compared, which is the analytics, research, and log management for the big data. So it is having 30 days of trial, and then we have to pay to them for using that tool. And ELK is open source, so we have to use it freely throughout our project. So ELK is an open source ELK stack, which is used. So some of the features are here, which are compared with all these three tools. So, so for the searching part, so in the searching, Splunk and Sumologic is having a great search. For ELK, we have to have some integration with it. And for the analysis and visualization dashboard, both are same. Means like this only we are having that we have to have the integration. Only after the integration, we can have this feature in ELK. Then SaaS setup is also there, software as a service setup for all the three tools. On-premises setup. On-premises setup means the everything, the resources is in our company only. We are not using others. So it's a on-premises setup. So the next is plugins and integrations. So all the three tools are supporting this feature. Input and data type. For that we need plugins. So in the ELK we are having plugins like input, output, filter. These are some of the plugins that in the ELK. So customer support, it is available but not proficient in Sumologic and ELK. And in documentation and community, it's available in ELK but not in Sumologic. So all these features are in Splunk, but it's a paid tool. So whenever we require something that to be developed free of cost, then we can go for the ELK. So this is a sample Splunk dashboard, which I have referred from one of the site that have just written in the reference. This is the Sumologic, and this is the ELK, which is having a different visualizations used, like heat map, tree map. Then the goals are used, the vertical bar, horizontal bar, all that, pie charts also used. So how the ELK is working is that we are getting the log file. So this log files is from a different clients. So that is given to the Logstash. Logstash will read that data and it will segregate whatever the information that we want. That will be stored in the Elasticsearch in the indexing part of the Elasticsearch, and then it will that index will be shown on the Kibana dashboard. So the Kibana dashboard, here we will see the different types of the visualizations and see the data of that particular index. So here I'm just want to just highlight that Elasticsearch is nothing but we can consider as a database. So it's the row we can consider as a document, and the index we can consider as a table. So in the table we are having different rows. Likewise, in a indexing, in the index we can have a different documents. So this is the architecture of the project for which we use this ELK and AWS services. So which receives the log from the different clients. Then there is a S3 bucket, which will have the right event or trigger. So whatever is there is, suppose any log is coming, then it will trigger to a transformation lambda, and then this lambda will read the Parquet data. It will decrypt or it can decode the data which is in the format of encoded form, and transform the record to the Kinesis Firehose. From that, it will go to the correct data, the transform data will be on the dashboard, which will be displayed. And if there is any issue in this data, then it will be sent to a failed records will be sent to a S3 for retry. Afterwards, we can retry it, or we can analyze why this record has been failed. So these are the different transformation steps that is followed in the transformation lambda code. Here the lambda code is written in Python, and these are the steps that have been followed. That is, read the Parquet data, post the data, transform the data, and load the Parquet file, lambda handler, exception handler, JSON decode, and handling the encrypted and plain text data. Both we are handling over here. If it is encrypted, then we have to decrypt that data, and then we have to handle that. And if it is a plain data, then we are directly handling that data. So visualization of Kinesis data flow, how it works. We will get the data from app server or apps to Kinesis Firehose. Through that, it will go to the Lambda function, and here the request response of the S3 bucket will be done. Here the gathering of the data, processed and analyze the data, and quickly respond to a new information to it, and gain the timely insights. And it will inject the real time of data in the machine for the machine learning and analytics, and it will show to it will be given to the Elastic, and through that it will be shown on the Kibana to the end user. So AWS, so the basics of AWS, Amazon Web Services are which is having AWS account, users, and services. So account is at the global level. We can having the account that is for the billing account form, for the IAM, that is identify and access management part, for the route 53, which is nothing but the DNS, we can say domain name service, which is a smart system for the route 53 of AWS. Then that account will have a IAM users, and it will be given to a different regions. So so at the regions level, it will be having S3 and DynamoDB. DynamoDB is NoSQL database, and S3 is a simple service storage, which will be given over here. And the last one is about the AC, that is AZ, that is available zones. So different zones are available, and that zones will have the EC2 instances, the RDS and EBS. So that is balancing systems, and the RDS is a SQL database. So these are the application flow for the AWS services. This is sample application I am showing, as I cannot show the exact the application flow of my system, as it's the company policies. We cannot show that. So here, if we compare it with the application that we are using previously, we were having the private network, but in AWS we are having VPC, that is virtual private cloud network. Over here we will be having VM, virtual machines we are using, but in the AWS we are using EC2, that is for the instances where we can deploy the different we can say different our applications over here in EC2. Then we are having the next one, we are having the media files, which will be given to this particular part. So here we are having content filter. So content filter we are doing using the AWS recognition part. External storage that is replaced by the S3 AWS S3. So Lambda file we are using for the video converter. Suppose there is one video which we are going through on the laptop that we have to see on the mobile, then we should have some video converter. So that converter will be done by the Lambda, by using the Lambda, by writing some code in the Python.
You have having last 2 minutes.
Okay, sir. Yeah. Then there is a kinesis where we have to have the click stream analysis. So we have to have that, and then we are having EMR for the Spark and Hadoop related part, and then we are having Redshift, which is for the data warehouse, and the QuickSight is for the showing the data on the dashboard. So here we are having the SQL database. Here this is a non-SQL database. So for cache, we are using the Elastic Cache. So there is also WAF, that is a wire. It's a firewall of the AWS for us to use. Then the result is that we are having data. We will get the healthcare data in this form of the CSV format. Then we will store it into the Elasticsearch under the index as HIV/AIDS data. And in the logstash, we are defining that what are the different the parameters that we required, or the different fields that we required in this particular data that we can define, and we can provide the index to it in the output plugin. So this particular index will be created in this Kibana dashboard, and we will see the data in the document format. Here we can expand that document in a form, that is table form or JSON form. In the table form, we will get the field and the values form, and in the JSON we can have the key value pair like this. Then healthcare data in the Kibana look like this one. We can also provide different filtering, like here I'm giving the filter that gender should be male.
Madam, please go to.
And there is,
Madam,
we can.
conclude.
Yes, sir. So this is the dashboard that is showing on the ELK one. So this is the different for the web traffic data. Conclusion is that the studies demonstrate for the dashboards in Kibana, and it is for the companies for the commercial part of the cloud, and it's a low cost for the relocation by the Amazon for the existing companies infrastructure to more or to AWS. These are some of the references that I have gone through. So thank you, sir. Thank you all. Any questions, please?
Hello.
Yes.
Hello.
Yes, sir. Yes, sir.
Yeah, yes, madam. Good presentation, madam.
Thank you, sir.
Okay. You decoding and decryption data.
Yes, sir.
So what are the mechanism used for decode or decryption the data?
So for decoding and decryption data, we are using in the Python we have written the code in such a way that it will decode that for example patient ID is there. So patient ID, we don't want to disclose the patient ID or the patient name to the end
No,
user.
madam.
So
what I am asking, specific any decoding or decryption mechanisms are used?
Yes, sir. We are using that using
What
the
is the name of
management
mechanism?
system. So
What is the
KMS
name
we
of
are
mechanism?
using. Sir, KMS we are using of AWS service.
Okay. So second question is, so in data flow model, you are
Yes, sir.
using any protocol or any specific process? Any protocols are using in data flow? In data flow mechanism.
In the data flow mechanism, we are using Kinesis of the AWS service part, where they are also providing us the security and all that.
Okay.
Yeah.
Any specific protocol?
A specific protocol, it's an internal they have built, so I'm not aware of that. Which
Any two protocol name, madam? You know?
Yeah, the socket secure layer protocol and TLS protocol they have used in one of the service.
Okay. So as per your architecture, what
Yes,
is the
sir.
importance of VPC?
Could you please repeat, sir, question?
VPC. What is the importance of VPC? Virtual
VPC.
private.
Okay. Yes. So it's a virtual private cloud. So
What is the abbreviation of VPC?
it's a virtual private cloud.
Okay. Any purpose of VPC, madam, in your diagram? What is the
Yes,
use
sir.
of VPC? Okay, madam. In AWS security services, so
Yes,
what are
sir.
the specific services you are using?
We are
Any
using
name of the
EC2.
service? Sir?
Yes, EC2 service we are using, S3 service we are using, Kinesis we are using, and we are using IAM for the authentication and authorization of that particular field, that is particular user to give the authentication and authorization part. KMS we are using for key management system, where we are having the, as we just discussed about the encrypted data and decrypted data for that part. So key value pair is there that we are having. And we are also using the WAF, that is the firewall of AWS to get
Okay,
the
madam. Any specific mechanism used for data retrieval?
data filtering part. We are using Logstash, sir.
Sorry.
Uh, for data filtration part, now we are using the Logstash in
No,
the Elk stack.
what I am asking for data retrieve. So what are the mechanism you are using? Any
For
specific
data
mechanism is
retrieval
used?
part.
Retrieval part.
Yeah. So for retrieval part, we are using Elasticsearch. In that, the indexing is there, and we are fetching that index to show on the Kibana dashboard.
Okay, thank you.
Yeah, thank you, sir.